Hey everybody, this is Larry. This is me doing my daily. This is the last day of the daily challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. 1626, best team with no conflicts. Day 31 of January Leetcode Daily Challenge. Hope you have the streak going and everything. If not, that's okay too. Sometimes these streaks are just like this gamification thing, right? Like all you can do is do your best and just learn a little bit and give yourself time to rest and take a break. I'm saying this because I just came back from the gym and I am tired, and I think that's the one thing that maybe is a sidetrack. But when I was younger, I definitely did not take recovery into account. I was always like, go 110%, and then like until I get injured, and then that's my recovery, is not doing anything because I injured myself. And I think there is probably like an analogy there somewhere with Leetcode. I've been saying that a lot in general. It's just um, the question that I get most often is what is the best thing to do. But honestly, my opinion is that they obviously do things that are a little bit this idea of deliberate practice, where you do things that are a little bit harder than so that you're forced to kind of understand a little bit, right? Like learning, right? If you do the same thing, that's practicing for a different thing, maybe implementation, maybe for speed or something like this. But if you want to learn harder problems, well, you have to work on slightly harder problems that you can maybe solve if you really kind of reach for it, and like a problem that you could solve with an hour or something like this, right? Yeah. So that's basically, and I think the other part of that is that unless and some people might have real time constraints, right, with respect to like, okay, I have an interview in 2 weeks and I haven't prepared for it. Well, then it is what it is, and you try to do the best you can. But if you're in the fortunate position of having more time and more deliberateness to kind of figure things out, it all really is just about consistency, and everything kind of builds on each other. And the things that you see me do, and one thing that I started this channel about is because I want people to see how hard things are, even for someone who's really good per se. Hopefully that doesn't come up as a humble brag, but no, I mean, I consider myself pretty confident about it, and it's still, from time to time I still struggle, right? Sometimes you have good days, sometimes you have bad days, and even on top of that, some problems you just, like, it's a huge domain, all these computer science programming things, right? Like, I may be really, really good at dynamic programming. I don't know if that's true, but I may be really, really bad at greedy problems, for example, right? So, and sometimes you get lucky, sometimes you don't. The ratings is just like an average of all these things in some weighted kind of way. But yeah, yeah, and so consistency over length of time, and you have this idea of learning in general. You can really, your brain, generally speaking, is my understanding of the literature. I'm not a neuroscientist or anything like this, so definitely do your own research. But my understanding is that a lot of your learning is actually done at night when you're sleeping and so forth, trying to recover what you had deliberately done the day before, and that takes time no matter what, right? And then it's about getting enough reps that, okay, the next time I see this problem, maybe I'll think about it in a different way. Now that I have another tool, or maybe I understand this tool a little bit better. Anyway, last day of the month. Wait, is it? Oh yeah. Last day of the month, so a little bit of a rant to start. I don't know if it's a rant. Hopefully, someone finds it useful. Leave in the comments what you think, and how you've been doing with this month. Yeah, one thing that I've been trying to do this year is that I've been doing. I've been taking cold showers. Also, it's like a sidetrack. So, and I'm telling you, it's very draining, but it's very exciting. So I don't know. Let me know in the comments if you have done this cold shower thing. And yeah, okay. 4 minutes, 5 minutes into the video, let's actually start working this problem. A little bit of rant because I feel like I've been getting a lot of these questions lately. Maybe I just need to do an AMA or something. But anyway, today's problem is 1626, best team with no conflicts. you're a manager of a basketball team. For an upcoming tournament, you want to choose the team with the highest overall score. The score of the team is the sum of scores of all the players in the team. However, the basketball team is not allowed to have conflicts. The conflicts exist if a younger player has a strictly higher score than an older player. A conflict does not occur between players of the same age. Okay, so we have to return. Given two lists, return the highest overall score of all possible teams. What's the score? The sum of all the things. Okay. And n could be something big. Oh, only 1,000. That's actually surprising, to be honest. I wish I didn't see that yet, because to be honest, given that n is equal to 1,000, you immediately, or is by you I mean me, start thinking about dynamic programming. The reason why is because in this case you can think of, like, I think the n squared dynamic programming is kind of trivial. Wait, that's not true, is it? Maybe. Maybe we still need it, to be honest. But I am my initial innate, or intuition, maybe that's a better word. My initial intuition was that I can do some kind of sorting and then linear after the sorting, which is why I'm a little bit now thinking like, why is n 1,000? Maybe I'm also like, you know, big braining myself a little bit too much and confusing myself. And the reason why I say this is that I think it is just a sorting problem, is what I believe. The reason why I say that is because it is just a lot of, it's very similar to a few problems that we have seen on Leetcode and that I've seen on Leetcode, on Codeforce. This idea that, you know, maybe there's still a DP based on it, but yeah, okay. Anyway, enough about kind of intuitions and stuff. Let's actually think about the problem, right? So basically, what are we doing? Younger player has a higher score, right? So what does that mean? That means that it may still be DP, to be honest. Maybe I'm thinking about it a little bit weird, but you still need to sort. So then you can kind of keep the DP symbol. But but basically the idea is that we sort in some way such that when you scan from left to right, or in whichever direction you prefer, then you only have to care about the other dimension, right? For example, if we sort both these arrays by age, then we can just take then it becomes the LIC, right? The longest increasing subsequence. Well, not quite the LIC, where LIC is the longest increasing subsequence. Not Long Island City, if you're from New York, but the sum of those sequences, right? Which I suppose is an n squared solution. Maybe that is still DP then, and maybe that's good enough. I think in my mind I'm trying to think whether it makes sense to sort. Oh, sorry. Like, is there a linear sort or linear after sorting solution? I guess not. Because I think the something is making it so that you cannot be greedy without being more exhaustive. Yeah, I mean, I think that's true. Let's do the DP thing then. So basically the idea is that, you know, we have some tools in our thing, right? We have longest increasing subsequence, kind of, this one is an n square algorithm. I know that there's an n log n per se, but that's very specific to the LIS. Right now we want the sum of the longest increasing, well, not the longest then, right? It's like highest, whatever. So it's kind of, but the recurrence is very similar. It's just that the function doesn't allow it to be binary search, so it's not the n log n variation or something like this. And then basically, and that's given a 1D array, right? So basically now we want to sort these things by the ages so that we have yeah, so then we can only care about one thing, and if we and if the ages are already if the ages are already sorted, then going from left to right, it does you already you already reduce this to this problem. So okay, let's get started on it. So let's use SIP score ages in this for this. Then we maybe we can do something like we want to sort by age, right? Lowest first, and then S. So let's just do something like this, and then we can sort it by this. And then now we have I don't know, players, say, right? So now we have the players in that way, n is equal to the length of players. Is the sorted return a list or an iterator? I actually don't know. I guess we'll find out, because if it returns an iterator, it'll just tell me that you can't do a length on iterator or something, right? Maybe, I don't know. Actually, I never know. I always confuse what. Let's just make sure that's true. Otherwise, sometimes if you do the loop again, then like it doesn't work, and you're like, why is this working for 10 years? Okay, so then now let's do the highest increasing subsequences, I'm calling it now. So you just say get best maybe from an index, and this does require some understanding of the other dynamic programming. So I'm not going to go too much about it. This is basically the idea, or at least I'm not going from first principles. We're just going from the idea that, okay, with the index represent the suffix of these players array, starting at that index, and then you solve the best for the suffix of that index, right? So okay, so if index is equal to n, then we return 0 because there's no more players to have. The array size is 0. Otherwise, we have, do we add this player or not, right? Yeah. But I forget how to write it precisely. It's been a while, because usually I do it bottoms up, but I find it slightly easier to kind of do it this way. But yeah, so basically everyone to the right of it is going to have either have an older age or same age but a higher score. So that's basically the idea. And then basically for this number, we either take it or we don't. If we don't take it, so best is equal to get best of index plus 1, because that means that we just don't take it, right? Okay. That means that we don't take this player, so then the best score is going to be the next player. Otherwise, let's say we do take it, then what does that mean, right? That means that we have to go to the next index. So let's just is this right? Am I doing well? I mean, it is kind of right, but I feel like this is doing it weirdly. I think I'm doing the not take. No, I think you have to take it. I think this is a variation where you cannot just skip it like this. That's why I think I'm getting a little confused. And that's also where the experience comes in, is that, you have spidey senses of, I made this mistake before, I think, so let's not do it again, right? So basically now, yeah, and then the next item is going to be, say, oh, this is starting from index plus 1 to, and then this is basically going to go to J. Okay, I see. So now in this case, the sentinel case is that this is the last item, or base case is that this is the last item on the thing, because I think this thing doesn't anymore. And if this is the last item, then it's going to be scores of index, right? Or this is the last player on the list, or the oldest person on the list, or whatever you want to say. And then this is if we try to make an attempt, which is that if score sub j is greater than score sub index or equal to it. this is a little bit awkward because only if a younger player is strictly higher than, okay. I mean, okay, it's not that awkward, but basically it's saying that if it's to the right, then it's that, or it's just that I spotted an edge case. If they're equal, then the age has to be equal, right? And then that would be the next player we add. So you go to J plus score sub index, and then best is you go to max of this thing, I suppose. And then we turn best at the end. That's basically the, ooh, I already wrote that. Get best of 0. In this case, we don't get best of 0 anymore because we can, in theory, skip the first player. Don't know if it would ever, I guess it could make sense. The youngest player could have like 1,000,000 score, and then you skip the other ones, even though they might add up better. So yeah, so then return something like this, right? Let's give it a spin. Ooh, I do mean that. Wait, how that? Why? Wow, this is such a weird typo. Ages of index. Okay, so this looks good. Great. Let's look at this. This looks not as good. A little bit sad. How do you get 15? Basically, all right. Let's print it out real quick, so I have a better visualization. It's all about a visualization. Okay, so I have this thing. Oh. You want these two plus the 6. Did I miss that? That should be okay. J should go to N, and then we're Gucci. Why would it return 15? What is 15? Am I doing something math wrong? How do you even get 15? Huh. Dong dong dong, the plot thickens. Maybe I have a really silly typo or something. But I think this fixed that part. Oh, 15 is this plus these two. But that wouldn't work, right? Did I mess this up? Did I sort it by the wrong thing? Oh, I am dumb. I'm dumb. I end up using scores and whatever, but I never used players. What we actually want is players. Players of index, and then the score is actually the 1. We probably should have just there is a clean way to do it, or in some languages, there is a clean way to do it. And maybe I should use the name tuple or something. Because this looks really ugly, to be honest. But so this part I could have just followed the equal exactly. But oh well. Okay, there you go. I was using the wrong arrays because I don't know, just maybe force of habit or something. Okay, this is why you have test cases and run them, right? Okay, so yeah. So I mean, the thing that I always say now is that obviously this is going to be too slow for any big number of n. This actually goes like ridiculous, but. So the thing you do is that, of course, we have to remember to memorize, and that's pretty much it. Why can we memorize? Because for the same input, we get the same output, right? Pretty basic. Yeah, an index, of course, there's only 0 and different possible inputs, one for each index of the suffix. And so, yeah. And of course, there's an O of n loop in here, so it's just going to be O of n squared time, right? Which, as a reminder, is the way that I always say it, because I think people kind of hand wave it a little bit, is just the number of inputs times time per input, which gets you total time if you do the dimensional analysis, right? So, okay. So yeah, if cache of index, then we return cache of index. Or I wrote it wrong, but I think I have it as has cache. And then otherwise, as cache of index is equal to true, cache of index is equal to best, and we're already happy after we said cache is equal to none times n plus 1, and has cache is equal to also 4 times n plus 1. Now it's going to be faster. Let's give it submit. Uh-oh. If it times out, I'm going, oh, worse than that. I output 1, but I expected 10. Did I mess this up? Did I mess up the indexes? That's actually surprising, to be honest. I mean, also like 133 cases. What happened? Huh? That is actually surprising. I am shocked. But oh, scores could be this. Oh, I misread this. I think. Okay, so a conflict if it's strictly higher. So no conflict is if it's higher or equal to. I think I misread that a little bit. Okay, fine. I mean, my code does what I wanted to do, but I think I misinterpreted what they meant by conflict and not having them. There's like a few double negatives in there. That's why. But yeah, I got a coin or whatever. I think I made a few mistakes last time too. But how did that happen? Same idea though. So yeah, yeah, n squared time, O of n space, and that's all I have for this one. Let me know what you think. Yeah, hope you had a great month. Let's start February strong, and yeah, stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.